What happens when humanity decides to hide its most powerful weapons beneath the sea? What kind of engineering can keep a city-sized machine alive in the black depths where light dies, pressure crushes steel, and sound becomes a weapon? And what if those machines are now so big that the ocean itself can barely contain them? This is the story of submarines, the ultimate expression of stealth, endurance, and mechanical genius. From the first underwater tin cans to today's nuclear fortresses, this is extreme technology. Big, bigger, biggest. The ocean's challenge. The ocean has always been the most hostile environment on Earth. It's not just the darkness or the cold, it's the pressure. Every 10 meters you descend, the weight of the world increases by another atmosphere. At just a few hundred meters, that pressure can crush metal like paper. For centuries, humans dreamed of traveling under the sea, but those dreams usually ended in disaster. It wasn't until engineers began to truly understand the language of physics, buoyancy, pressure, and propulsive propulsion that we began to tame the deep. The first real submarine was barely big enough for one man. A small, hand-cranked wooden sphere called the Turtle. In 1776, it made history as the first underwater attack craft. Its mission, to drill a bomb into the hull of a British warship. It failed. The air ran out. The pilot barely survived. But the seed of an idea had been planted, a weapon that could strike unseen, where no fleet could defend itself. The idea would grow over centuries into one of the most fearsome technologies on Earth. The first big beasts. By the early 20th century, industrial power had caught up to imagination. Diesel engines, electric motors, and hardened steel changed everything. The world's navies began building submarines that could travel hundreds of miles and carry torpedoes powerful enough to sink battleships. The German U-boats of World War I were the first to truly terrorize the seas. Each was around 60 meters long, carrying 30 men and a handful of torpedoes. They were noisy, cramped, and deadly. Inside, the air was thick with oil and sweat. Outside, destroyers hunted them with sonar and depth charges. The average mission lasted days. The average life expectancy? Much less. Yet the strategy worked. By 1917, U-boats had sunk over 6 million tons of Allied shipping, and the world had learned something terrifying. You didn't need a massive fleet to rule the oceans anymore. You just needed a few shadows. Still, the U-boats had a fatal flaw. They were only part-time submarines. Their diesel engines required air, forcing them to surface regularly. Every time they did, they risked being spotted and destroyed. To go deeper and stay longer, they'd need a new kind of power. The war that made them bigger. World War II was the crucible that forged the modern submarine. Every major navy raced to improve range, endurance, and stealth. Germany's answer was the Type 21, the first submarine designed to spend most of its time underwater. It was sleeker, faster, and quieter, powered by massive batteries and streamlined hulls. At 76 meters long, it could reach 17 knots submerged. It was, by the standards of the day, an enormous machine that seemed to defy the ocean. But across the Atlantic, another revolution was brewing. The U.S. Navy's Gato-class submarines were built not just for coastal defense, but for global domination. Each one stretched nearly 100 meters and carried enough fuel to cross the Pacific. They prowled Japanese supply lines, crippling an empire from beneath the waves. For the men inside, life was a test of endurance. Submarines were called iron coffins for a reason. Temperatures soared, the air stank of diesel, and space was so tight that privacy didn't exist. When depth charges exploded nearby, the hull shuddered like it might collapse. Every dive was a gamble, but those gambles helped win the war. By 1945, the world had learned two things. Submarines could change the outcome of global conflict, and they were only getting bigger. The birth of the nuclear age. When the Second World War ended, a new kind of war began, One fought in silence and shadows. The Cold War was a battle of nerves, numbers, and above all, technology. The oceans became the new frontier, and submarines were its frontier soldiers. In 1954, the USS Nautilus changed history. It was the world's first nuclear-powered submarine, and it didn't just break record, it rewrote them. No more surfacing for air, no more refueling every few weeks. Its reactor could run for years. For the first time, a submarine could remain submerged indefinitely, limited only by the endurance of its crew and the food they could carry. It was the beginning of something terrifying. Machines that could vanish for months at a time, undetectable, unstoppable, and armed with weapons that could destroy nations. But nuclear power didn't just make submarines stronger, it made them bigger. The reactor itself required enormous space for shielding and cooling. And when engineers realized they could use that power to launch missiles, the scale exploded. To fit nuclear missiles, you needed vertical silos, larger hulls, and more structural strength. Thus was born a new species, the Ballistic Missile Submarine, or SSBN. Bigger, the underwater cities. The first of these giants was the USS George Washington. Commissioned in 1960, it was 116 meters long and carried 16 Polaris nuclear missiles. Each missile could strike targets over 2,000 kilometers away. For the first time in human history, a single submarine could unleash more firepower than an entire fleet. Inside, life changed too. The crew no longer shared bunks and shifts. They lived in relative comfort, with air conditioning, full galleys, and even small libraries. They weren't just sailors, they were caretakers of the apocalypse. Each mission was a 70-day patrol of silence, deep under the world's oceans, waiting for orders they hoped would never come. The George Washington was followed by the Ethan Allen, Lafayette, and Ohio classes, each bigger, quieter, and more powerful than the last. The Soviets answered with their own monsters, the Delta class, the Yankee, and the legendary Typhoon. By the 1980s, submarines had reached lengths of over 170 meters, longer than 2 football fields. They displaced 48,000 tons of water when fully submerged. That's not a boat, that's a moving mountain of steel. To operate one was to run a small city underwater. Nuclear engineers, weapons specialists, chefs, medics, sonar operators. More than 150 men lived and worked in a sealed world of humming machinery and artificial light. But bigger also meant more complex. Every new ton of steel added challenges in balance, buoyancy, and noise. At these sizes, stealth was no longer just about silence, it was about physics. Water is an unforgiving medium. Every vibration, every moving part echoes for miles. The race was now about who could make the biggest submarine the quietest. Biggest, the Typhoon and beyond. When the Soviet Navy launched the Typhoon-class submarine in 1980, the world gasped. It wasn't just big, it was colossal. At 175 meters long and 23 meters wide, it remains the largest submarine ever built. Twin pressure hulls ran side by side, connected by massive structural beams. It carried 20 R-39 ballistic missiles, each with 10 nuclear warheads, enough to destroy half the planet. Life inside the Typhoon was almost luxurious by naval standards. It had a swimming pool, a sauna, even a gym. Why? Because missions could last 6 months or more, trapped under ice, hundreds of meters deep in the Arctic Ocean. But its true power lay not in comfort, but in invisibility. The Typhoon could hide beneath the polar ice cap, completely undetectable. There, surrounded by thousands of miles of frozen silence, it could wait, ready to end civilization at a moment's notice. To maintain control, the Soviets developed complex communication systems that could send messages through the ocean itself, using extremely low-frequency radio waves that could penetrate deep water. The Americans did the same. It was like building a telephone line to the abyss. The Typhoon symbolized everything terrifying and brilliant about human engineering. strength, endurance, and an obsession with being bigger. The hidden evolution. But the story didn't stop there. By the 1990s, both sides realized something important. Bigger isn't always better. The ocean rewards stealth over size. Massive submarines are powerful, but they're also expensive, noisy, and hard to hide. So the next generation of submarines became paradoxes. Smaller in crew, larger in capability. The U.S. Ohio-class SSBNs were modified to the SSGNs, replacing nuclear missiles with 154 Tomahawk cruise missiles. The Seawolf and Virginia classes used modular design, cutting-edge sonar, and anechoic coatings that absorb sound. They weren't built to dominate by size, but by silence. And yet, in terms of raw engineering, these vessels were still enormous. A single Virginia-class submarine contains over 130 kilometers of wiring, a reactor core that can run for 33 years, and a hull strong enough to withstand 500 meters in pressure. Every valve, bolt, and gasket is a lesson in extreme technology. The deeper you go, the stronger you must be, and the bigger you build, the more precise every detail has to become. The balance between size and stealth, that's the real art of submarine design. The science of survival. At great depths, the ocean wants to kill you. Pressure pushes in from every side. Water seeps through microscopic cracks, and machinery never sleeps. The steel hulls of submarines are marvels of geometry and metallurgy. Cylinders shaped to distribute stress evenly, made from high-tensile alloys that can flex without breaking. When a submarine dives, its hull compresses slightly, mere millimeters, but enough to change the internal volume and pressure. Every dive is a dance between control and collapse. Inside, life runs on routine. Air is recycled through scrubbers that remove carbon dioxide. Fresh water is made from seawater using distillation units. Even the smell is engineered. Chemical filters remove the trace of metal and oil. In a world with no sunlight, technology replaces every element of nature. A modern nuclear submarine can operate for months without surfacing, powered by the same reaction that fuels the stars. Its reactor heats water into steam, driving turbines that generate electricity. No fuel stops, no refueling, just motion. Endless, silent, precise. That's what makes these machines so extraordinary. They are the closest thing humanity has ever built to a self-contained ecosystem. They survive in a place no human could endure alone. The modern Titans. Today's largest active submarines are the U.S. Navy's Ohio class and the Russian Borei class. The Ohio measures 170 meters and carries Trident II missiles with multiple independently targeted warheads. Each warhead can hit a different city, thousands of kilometers apart. It's the definition of deterrence, destruction made invisible. The Borei is slightly smaller, but more advanced in stealth. It uses a pump jet propulsion system instead of a traditional propeller, reducing noise to near silence. When cruising, it's quieter than a school of fish. These submarines represent the pinnacle of human engineering, enormous, deadly, and designed to never be seen. Yet paradoxically, their true purpose is peace. Their existence prevents wars. Because when every superpower knows that an invisible submarine could retaliate from anywhere on Earth, the only rational choice is not to fight. It's a strange irony. The biggest machines ever built for war now serve as guardians of peace. The future, beyond the biggest. So what comes next? Will submarines get even bigger, or will they vanish into silence? Engineers are already designing autonomous underwater vehicles, robot submarines that can dive deeper than any human-crewed vessel. Some are small enough to fit in a garage. Others are so large they blur the line between ship and machine intelligence. They can patrol oceans for months, powered by advanced reactors or fuel cells. They don't sleep, they don't eat, and they don't need air. Then there are concepts like the U.S. Navy's Columbia class, the next generation of SSBNs. At 171 meters, they'll carry fewer missiles than their predecessors, but with unmatched stealth and efficiency. Each one costs more than $8 billion, the price of silence, secrecy, and survival. In the near future, submarines may even act as undersea data centers, drone carriers, or platforms for deep-sea exploration. Their purpose will expand, from weapons of deterrence to tools of discovery. Because the deeper we go, the more we realize how little we know about our own planet. The human element. Behind every submarine, no matter how large or advanced, there's a crew. People who live in steel corridors no wider than a hallway, sharing recycled air and artificial light for months. They train for every possibility: fire, flood, reactor failure. Because in the deep, there's no rescue. Their courage is as vital as the technology that surrounds them. For them, biggest doesn't mean comfort. It means responsibility. Every valve they turn, every sonar ping they interpret, every silence they maintain could determine the fate of millions. Submariners live with a paradox. They serve inside the most destructive machines ever built, yet their mission is to prevent destruction. They operate in the blackest depths of the sea, yet their work preserves life on the surface. That's what makes them, and the submarines they guide, extraordinary. The ocean's shadow. From the one-man turtle to the 48,000-ton Typhoon, the journey of the submarine mirrors humanity's journey toward mastering the impossible. Every generation has pushed deeper, farther, bigger, chasing control over an environment designed to destroy us. But even now, the ocean holds the upper hand. We can survive within it, barely, but we cannot conquer it. The submarines we build are not proof of dominance. They are proof of humility. They show how far we're willing to go to protect, to explore, and to understand. So the next time you look out across the sea, remember, somewhere beneath those waves, hidden in the silence, are the biggest machines ever built. Machines that hold our secrets, our fears, and our future. They are the giants of the deep. They are the unseen guardians of the world. And they remind us of one unshakable truth: that even in the darkest depths, human ingenuity finds a way to breathe. If you enjoy exploring how human ingenuity pushes the limits of what's possible, from the depths of the ocean to the edge of space, then stay with us. There are more stories like this waiting beneath the surface. Subscribe, and let's keep diving deeper together. Stay blessed and stay curious.